In this tutorial, we are going to talk about creating a simulation for your Onshape design using SimLab Composer. To access the Onshape Cloud Server from SimLab Composer, click on Cloud Import. Select Onshape from the Cloud Sources list. Enter your Onshape account's email and password and click OK. In this window, you can navigate the files on the cloud server. It is similar to the interface of the Onshape Cloud CAD system. You can access your documents, the files that you created, your shared files, and also the public server. Once you select a folder from the list, the contents of that folder will be displayed in the Documents list. Select a document to display all the elements included in that document. Click Import to access the selected design from Onshape's cloud server through SimLab Composer. This is a single piston mechanism designed using Onshape. Click on the Simulation bench to access the simulation options. You can either choose the parts you need to simulate, or click Detect to automatically convert any objects to solids that can be simulated by the physics engine in SimLab Composer. Click on Links to start adding joints and connect the parts of the model. Notice that hovering over the objects with your pointer highlights them in red, indicating that they are solids and can be simulated. Go to the Simulation tab and click on Parameters. This will grant you access to several options related to the simulation. In the Gravity section, set the Z value to 0 since you wouldn't need the gravitational force in this example. Click on Revolute to create a rotating joint. In the panel to the left, for Solid 1, click on the blue globe. For Solid 2, click on the crankshaft. Then click on the ring of the shaft to determine the axis of rotation. In this joint, it will be the y-axis. Click on Enable Motor and set the speed to a constant of 5. Setting the ground as the first ground solid in this case means that we want the crankshaft to generate the rotation by itself and not be influenced by the rotation of any other solid. Go to the Simulation tab and click Start to play the animation. The crankshaft is rotating now, but in turn, it must rotate the rod shaft connected to it. To connect the crankshaft to the rod, create a revolute joint. Set Solid 1 as the crankshaft and Solid 2 as the rod. Click on the upper rounded edge of the rod's bearing to set the axis of rotation. Now, the rod is rotating with the crankshaft, but, as you can see, the screw, bolts, and the lower part of the bearing is not moving along with the shaft. To resolve this, you can either merge all these objects into a single solid or by connecting them using fixed joints. Click on Fixed to create a fixed joint. Select the bolt as Solid 1 and the rod as Solid 2. Create another fixed joint and set the nut as Solid 1 and the rod as Solid 2. Follow the same steps to connect all the parts to the crank rod. To connect the crank rod to the piston, create a revolute joint and set Solid 1 to be the rod and Solid 2 to be the piston. Click on the ring of the pin to set the axis of rotation for the joint. Create a fixed joint and connect the pin to the piston. Go to the Simulation tab and click Start to play the animation. You can see that the piston is moving now, but the movement is not constrained by the cylinder. To force a directional movement for an object, create a prismatic joint. Select the piston as solid 1 and the cylinder as solid 2. Then click on the upper edge of the piston to set the direction of movement to vertical. The movement of the piston is now constrained by the cylinder, but the force is affecting the cylinder and forcing it to move with it. To prevent the cylinder from moving, select the cylinder and from the Properties panel, click the lock icon. Click Play to view the simulation. Now that the simulation is done, you have the option to turn it into an animation. Click on to Animation and set the frames per second for your animation. 30 is usually an optimum choice. Go to the Animation tab and click Play to play the simulation as an animation. Converting the simulation to an animation would allow you to export your design along with the animation to a 3D PDF document or on WebGL. SimLab Composer's simulation is very simple to use and can provide very accurate motion and objects interaction, using advanced mathematical and physical equations embedded within its engine. It can turn your Onshape models into living objects that won't require traditional methods of communication to explain, but rather a simple play button.